everybody, welcome to our webinar this afternoon. So before we get going, I'm just going to do some housekeeping bits. So if you have any technical issues during today's webinar, please just send a short message in the question box just on your right hand side of your screen. And during the webinar, we would like to invite you to ask any questions using the question box, which is also on the right hand side. And then at the end of the webinar, time permitting of course, we will try to answer as many of these as possible, and any we don't get round to we'll answer offline and share them with you along with a link to the recording after the webinar. So today's webinar is titled Microbiology Awareness, Establishing the Core Competencies for Manufacturing Personnel. Let's move on to the next slide. There we go. So my name is Rebecca McManus, and I'm a member of the commercial team here at RSSL, and I have a primary focus on sterile and non-sterile microbiology analysis. So I've been working at RSSL for 2 years now, and I started the company working as an analyst within the wet chemistry laboratory before moving to the commercial sales department at the start of this year, and I've recently taken on a more focused role supporting our microbiology clients. And so my role is to support clients that require a variety of microbiological testing, from routine microbial limit tests to more complex environmental monitoring or cleaning validation projects. So for those of you who are maybe new to RSSL or don't know who we are, RSSL, or Reading Scientific Services, we're a global contract research organisation supporting clients with a wide variety of analytical services. So we've been around for around 35 years, and we're based exclusively in the Reading area, and we have 4 separate sites. So for those of you who maybe don't know where Reading is, we're about 40 minutes west of London in Heathrow. So our 4 sites accommodate over 350 scientists working and supporting clients across 12 different technical areas, of which microbiology is just one of them. So we support clients globally, with clients all around Europe, as well as the US, and as far away as Singapore and Australia. We're a trusted CRO with a big emphasis on quality, science, and service. So this can be shown by our high Net Promoter Score. So because our clients sit close to one another, because our sites sit close to one another, we can show great agility to manage complex and multidiscipline projects. And we also have a dedicated multi-lab project manager and client liaison managers to ensure that those complex projects are kept on track and they're managed correctly. So the many technical areas we specialise in allow us to support a diverse range of biological, microbiological, chemical and physical analytical services. And this is across all phases of clinical development through to commercial release. So we're well positioned to support your projects utilising our state-of-the-art equipment and experienced technical team who can advise and support you throughout your manufacturing. So be that routine raw material testing, investigative support of any issues you may face, like impurities or foreign particles in your processes. We have a well-equipped and extensive microscopy department, which can help build a specific particle database for your manufacturing process. Our microbiological support is also extensive, where we can support all aspects of your Annex 1 compliance, including microbial identification of any environmental monitoring isolates or any unfortunate positives from your bioburden analysis using our state-of-the-art multi-talk system. And we also, of course, offer a range of turnaround times to ensure that you get those IDs through as soon as possible to help support your decisions on next steps. So enough of me and RSSL, I suppose. So I would now like to introduce you to our guest speaker, Dr. Tim Sandle. So I'm sure many of you have heard of Tim and subscribed to his many publications. However, just to give you a brief introduction, Tim has over 30 years of experience of microbial research and biopharmaceutical processing. Dr. Tim Sandle is a member of several editorial boards, and he's written over 900 book chapters, peer-reviewed papers, and technical articles relating to microbiology. Tim works for a pharmaceutical manufacturer in the UK, and he also finds time as an associate professor at both the University of Manchester and UCL. So now I'll pass over to Dr. Tim Sandle so we can begin our webinar.
Okay, thank you very much, Rebecca. There we go. Can you see my screen okay? Just double check.
Yes, fine, Tim.
Yeah, brilliant. Okay, well, thank you. And it's a great pleasure to be back with everyone again. So this webinar is focusing on training and looking at some of the key competencies that we'd want manufacturing personnel to be aware of. So if you've looked at things like EU GMP Annex 1, then you'll notice in there that it specifically calls out the fact that those working in pharmaceutical facilities need to have a basic understanding of microbiology, and also it mentions engineering, and then there's special requirements for those who deal with sterilization and sterile products. But this isn't only a regulatory requirement, because effective microbiology training is also key to contamination prevention. So there's like a practical use that we need to take advantage of. So this webinar is going to highlight some of the core competencies for manufacturing teams to uphold for microbial control and to help ensure product safety. And we'll look at some practical examples, including training materials and ways to assess outcomes. And we'll also touch upon some of the newer technologies that are available. So we have virtual reality, online learning, and so on. But it's also important that we evaluate training as well, because if we don't stand back and say, what did the participants actually learn, then we just have the danger of repeating the same thing over and over again. An important area in order to create training, to make sure we're getting value for money, is with developing training competencies. And by competencies, we're seeking to identify the specific skills, the knowledge that we wish to impart, the behaviors that we wish to create, that we want each individual to do in order to perform their job successfully. And developing a competency-based training program focuses on developing these specific areas. Now, focus here is with microbiology. But we're also seeking to make sure that the skills become embedded, the ways of thinking are there, so that people always have things like contamination control as part of their working mindset. And we're also seeking to increase efficiency. So if training is imparted well, then people become more effective and they become focusing on specific areas. And it can also help support professional growth, so that people can move around a company and apply their learning to different areas. And also we're aligning with business goals, because reducing contamination of the pharmaceutical product is always going to be essential to any business, because therefore we're avoiding batch rejection. Now, in thinking about some of the training competencies that we want manufacturing production personnel to be aware of, then a basic understanding of microbiology is very important. So knowing what microbes are, and then understanding sources of contamination. So where could contamination exist? Where could it emerge from? And then what are the specific risks should that contamination be transferred, say, to a product contact site, or actually directly into the product? And we also need to make sure that production personnel can perform aseptic techniques. Even if we're making a non-sterile product, we still want to avoid unnecessary cross-contamination. There's a lot around gowning and personnel hygiene, and we'll look at some examples of that shortly. It's also important to ensure that everyone understands the theory behind cleaning and disinfection, but also the practical application so that we can clean and disinfect with regularity. And I think it's also useful for manufacturing personnel to understand environmental monitoring and how they themselves can contribute to the contamination in the environment. And also, if we get things right, if we truly impart knowledge and then we capture knowledge that the manufacturing personnel themselves have, then we can effectively input into deviation. So there's a lot we can muster around that area. But even once we've developed competencies, we have to ensure that what we're trying to get across has been acknowledged and inbuilt into the trainee. So we do need a form of assessment. Often that's best supported by practical application, and from time to time for certain areas we will need to reassess those activities. So some sort of more detailed competencies that we could explore. These are some areas that I think are especially important for establishing the basics. So when we're thinking about a new employee into our pharmaceutical company, these are some of the areas that I think we should be focusing on. So gowning and hygiene. So we need clear procedures for donning protective clothing, clean room suits rather, and maintaining personal hygiene. But we need to make sure that the trainee can demonstrate that through practical application. We need to ensure that personnel understand what contamination is, where it comes from, how it might spread, how to prevent it, and the cleaning and disinfection protocols for equipment, for surfaces, and the overall clean room. We also need to get across behaviour, how people should behave within the clean room, and also things like movement as well, because as we've established in earlier webinars, the faster and more erratic somebody moves within the clean room, then the greater the concentration of particles that are produced. Risk awareness is an important area. So even just getting across the essentials of severity and likelihood. So if something isn't done, let's say we forget to sanitize something, or we miss a step for transferring something, then the likelihood of contamination will rise. And if, say, something's coming directly from outside, then the severity will also increase. And then there's things like what to do in an emergency, and what measures need to be taken. Let's say there was a building evacuation, then what's the contamination risk around that? And then we also need to consider equipment and supplies, particularly about what is and what is not suitable to go into the facility, and what kind of standards we should be focusing on. So I think if we can cover these sorts of areas and get those basics across within the, say, first month of a new starter, then that's a major step forward in seeking contamination control. But it's also important that any training engages with the staff. And particularly with younger generations, they're more used to things being very visual, for the use of video content, and also for training to be imparted sometimes in sort of shorter, sharper ways. It's also useful, I think, to do as much hands-on training as possible, and we'll look at some examples of that, as well as using visual and interactive methods. And I believe we can introduce that into gowning, hygiene, contamination control, and emergency procedures. So there's a lot we can do in trying to use that, and also helping to create a positive training culture. One particularly also one that the leadership in the company also backs and supports. So training needs to be far more than just a box to tick. So, I mean, certainly the worst thing we can do when we're approaching training is to say the objective is to produce a training record that an auditor can look at and everything looks fine, because we haven't actually imparted anything to anyone. So, you know, just to spend ages preparing a folder with lots of nice looking training documents in doesn't really achieve anything. It's also important that we minimize the amount of jargon that we use, and to put things in basic English. So for example, if we had an SOP that said excessive contamination minimization protocols must be used to avoid ingress. Now that doesn't really mean anything to anyone, and certainly for a trainee it would just go straight over their head. But if we said something like, move slowly when you enter the clean room, avoid fast steps because they will stir up contamination from the floor, that's a lot clearer for someone, I believe, to understand. Now, I'm going to come back to gowning a few times, and I'm always going to keep putting an importance on gowning, because this is the easiest way for contamination to enter the facility. If someone doesn't gown properly, it's easy to touch the outside with, say, bare hands, or not to put on mask and gloves correctly. And with just one simple mistake, then particles can spread. And this is really easy to show with visual, by having someone practically gown rather than just trying to run this through a lecture. It's also, my final point on this slide, is that it's really important to explain the why. The worst thing I believe you can do is to say to somebody, do this, without telling them why they should do it. And also, once you know the reason, then it sticks in the mind better, as well as feeling more engaged. So if you say, don't walk fast through a clean room, but you don't say why, but if you say, look, if you move quickly, if you start walking above you know, a certain rate, you will increase turbulence, which will push particles in more directions, and there's a greater chance those particles ending up in product. It becomes a little bit clearer. So to me, there's some key points there. So let's jump into some of the competencies. So if we consider basic microbiology, now there's a number of different things that we might want to get across to our trainee. And microbiology is a vast science, and microorganisms affect a huge number of processes, from helping plants to grow to breaking down in industrial waste. So there's a lot to cover. But here, I think we want to get across that there are certain microorganisms that could adversely affect the product. So if it's a sterile product, that's one set of risks. Or if there are we're making a non-sterile product and there are pathogens of concern, then this can also be a problem. So I think there's some key things within the basic microbiology realm that we want to get across. And I think another point in relation to that is that microorganisms are everywhere, and they're particularly in the general environment, and particularly where there is water. So emphasizing water is really really important, because water acts as both a vector and a growth source for contamination. I think it's also useful to get across that the relationship between people and microorganisms is very integrated. You know, we're carrying millions of microorganisms on our skin, and we're carrying millions of microorganisms within our bodies as well. And there's a few things, you know, I think to get across. One is the amount of skin that we shed each day, and the fact that at least 10% of the skin matter is going to be carrying microorganisms, and these will be carried in the airstream, and they're going to be distributed differently. Another thing is, you know, you go outside and you get that sort of earthy smell. Well, that smell is coming from microorganisms. It's not the smell of the soil itself, it's those microorganisms living there as well. So, and then a final point with this kind of ubiquity of microorganisms is that where the microorganism comes from gives great clues to where the contamination arose from. So we can track things like microorganisms that will come from human skin. Another point to get across is that where microorganisms occur, particularly within the pharmaceutical facility, is that there are often opportunities for microbial growth. So, you know, we can ask the trainees, you know, what do microorganisms need to survive? We can then also draw examples that, you know, whereas a lot of them do need water, a lot of fungi, for example, can grow under relatively dry conditions. And then, you know, we can list, you know, the types of things that microorganisms, you know, you may not think that they can utilize for food, but in fact, they can to a degree. So if you take disinfectants, then a lot of bacteria are able to break down disinfectant molecules, particularly when the concentration of that disinfectant slips away. They can use it as a carbon source. With antibiotics, we have antibiotic resistance. You know, we might think that a lot of bacteria won't grow in hydrochloric acid, but hydrochloric acid is what's in our stomachs, and the bacterium that causes ulcers, Helicobacter pylori, can readily grow under those conditions. Cyanide, some bacteria can break down cyanide because it's part of the nitrogen cycle for plant growth. And then even in a nuclear reactor, there are organisms like Denicococcus that can grow very well under sort of radioactive conditions. So there's, again, you know, I think here it's not only is that microbiology is interesting, but also the fact that you know, we might think, oh well, we've kind of given a token clean to that area, but there's nothing there that anything could grow on. Microorganisms have a remarkable capacity to survive and to grow. So there's some aspects there, but then the related area is is coming back to this concept of risk. And here, I think it's a useful exercise to get trainees to consider what kind of risks are there, where could contamination occur, how can we minimize that risk, how can we ourselves avoid being the vector, the point of transfer for that risk, and then what are the consequences should our product become contaminated? What kind of patient is it going to? Are they children? Are they vulnerable elderly people? Are they people with weakened immune systems? Various things like that. So I think again, it's getting that understanding, getting across why contamination could be a problem. And here it's never forgetting that at the end of the day, it's a patient, consumer, depending on the product, that will be receiving our product. And if you kind of think of a circular pattern, you know, if we start, let's say, start with the one that says Dr. Trust. So if we're making a pharmaceutical product that is administered, prescribed by a doctor, that doctor has to trust that the pharmaceutical company has made a product that's free of nasty microorganisms or completely free if it's a sterile product. The patient who takes the product that the doctor has prescribed is taking the doctor's word at trust. So in order to get to that point, you know, we need GMP, but we also need people to do the right thing. And this is where the training and the competencies and various factors come in, so that if people do the right thing, then the qualified person who would be releasing the product can then, you know, they want to be checking a number of things. They can check on the batch record, but it's that contextual information that they can be sure everybody's done the right thing. So again, I think this kind of circle of trust concept is a good one to get across. Now, thinking about sort of interactive ways, and a good way, I think, to get certain concepts across is through training and playing games and various things. So one such game, let's say again we're producing an injectable product, then you can get various body parts and ask people to put those in order of the level of protection that they impart. So here, if people are going to get it right, but it doesn't matter if they do or they don't, because you can explain it, but to get it right, then the bits of our bodies that are on the outside are giving greater protection. So nails, skin, hair, and so on. And then as we start to enter the inside of the body, then things like fat and muscle will impart a level of protection, but the area of weakest is blood. So anything that gets directly into the blood can cause things like sepsis. So it's the most vulnerable part of the body. So if we're making an injectable product, then we're bypassing all of the natural defenses of the body. So that's an important area, and you can often get that across with sort of fun things like this. In terms of people risks, so again, I think it's useful to emphasize why people are a risk to a clean room, the fact that we are walking microbiological hazards, we ourselves are sources of high numbers of particles, and as a point I mentioned earlier was the sheer amount of skin that we are shedding each day. It can be up to 10 grams. And we can also touch the wrong thing, we can gown inappropriately, and various things. So if you kind of think about, you know, a point of exercise about where all the contamination is coming from, and then we can try and get across about how can we control the human. So that's another area I think that can be used in a positive way to emphasize training. But it's also useful to use examples. So again, if we're using illustrations, we can think about what materials are most appropriate to restrict. So here we wouldn't have wood or cardboard or materials of natural origin. We can also use pictures like the one shown on the slide and ask the trainee to select, you know, what's wrong, how would they organize things differently, how would they control the obvious spots of contamination that are on the slide as it stands. Or we can get people to walk through things like how you would transfer items getting into a clean room, how would we make sure things weren't contaminated, how many layers we would require, and so on. So that can be equally quite effective. So there's some initial ideas there, but also we do need to have very clear, very solid training materials. So putting the time and effort into developing training materials is important, and we want to make sure that the training materials can convey information clearly, that they can be understood by both the trainer and the trainee, and that relate to appropriate GMPs. And I think, you know, if we're going to develop training notes so that the trainer's getting the right things across to the trainee, then having clear explanations of why, what, who, and when is really important. So let's say we've got a generic piece of equipment, or it might be a piece of lab instrumentation, but you know, it's important that the trainer gets across what does this equipment or process do, when does this happen, what are the potential consequences of not following the process properly, and why are these tasks critical, and why are these aspects essential to a good process outcome. So if we can get those aspects across, then I think we can go a step towards imparting knowledge in an effective way. So that's a little bit abstract. So let's now have a look at the area of gowning training. So if we're going to design a training module for someone to get gowned to enter into a clean room, then our specific objectives would include that we want to show the trainee the correct way to gown. And let's say this is an aseptic area. We want to make sure that we've educated the trainee on why gowning is so important and why it's important that it's performed correctly every time. So to get gowned in a compliant manner when nobody is watching. And we want to then prepare the trainee for a gowning test. So the future assessment is that they would perform the gowning, say without the gown touching the floor, and that would be assessed by the trainer. And there's some associated areas that I think we'd also want to try and communicate, say around process impact. So that's trying to get across the behaviours and practices within the clean room will have a profound effect on the suitability, the integrity of those areas, and we want to do things that are going to protect product, that in this case, let's say we're making an aseptic product, so we can't post-treat our product should anything get into that product. So we're going back to the patient, back to patient safety. So we need the correct use of procedures, and one of those areas is connecting to our process of gowning. And again, we want to be taking the trainee through a series of pictures and then the practice. So, but I think it's important to go through each step and explain why each step matters before jumping in to the practical scenario. So it's about putting on garments correctly, and we're seeking to control both microorganisms and particulates, and these are things that we cannot see. And we're using specially designed clean room garments, gloves, masks, head covers, and so on, to minimize the amount of contamination that could enter the clean room. And it's useful, I think, to get across that the suit is essentially one big filter. It's designed to allow the exchange of air, but to trap microorganisms within it. And then we want to sort of get across why this is necessary. So people are the biggest source of contamination. So we need to do our best that before anyone gets into the clean room, that that risk is minimized. And the way we can do that is through effective gowning. Also, if operators have worked elsewhere in the facility and they're entering, say, an aseptic area for the first time, then they might be familiar with certain aspects, but things are going to be a little bit different. So we want to get across that gowning for grade B is a bit different from, say, going into grade C or grade D area. For example, goggles need to be worn, sterile overboots need to be worn, long gloves might need to be worn. So it's getting across those differences and why those differences matter. And then it's about the process, the technique of gowning, how it needs to be controlled. It needs to be done in a slow and deliberate way. That the changing room itself is still a clean room. And perhaps the most important thing, and again, this is why emphasizing things like the contamination sources and the vectors and things, is that if air containing particles, microorganisms on those particles is not extracted, then it's those particles are gonna head for the nearest large horizontal surface, and that's going to be the floor. So if the gown hits the floor, then we're going to be pulling up contamination and resuspending that over ourselves. And if people are coming into a facility for the first time, then they might see the gowning process as very complicated. So why outdoor clothing needs to be removed. People may find the concept of removing makeup a bit strange, but if we can get across things like, say, mascara can generate 3 million particles an hour, then you can get across why the integrity of the clothing would be compromised. Also, the removal of jewelry as well can be a sensitive area, but it's also going across that often you're going to get high concentrations of microorganisms in association with those certain items of jewelry. And then perhaps, again, going back to aseptics, the most important thing to get across is that there shouldn't be any exposed skin. So any exposed skin is going to be a source of contamination, a source of concern. And then when it comes to the sort of practical aspects, so these are sort of notes that might be in a training manual that the trainers demonstrating to the trainee as they go through the gowning process. But it's about breaking down everything into key steps and making sure everything is captured and everything is explained. So the idea of things being multiple wrapped, about spraying surfaces, disinfecting surfaces before we put wrapped gowns down, otherwise we're just transferring contamination back to the packet, back onto our hands, and then potentially onto the gown, about putting gloves on, about how to fit the face mask correctly. Then about the importance of glove disinfection. So there will often be a target time and a particular pattern of the technique that needs repeating. Then the sequence, so putting on a hood, then the suit rather than the other way around, because that avoids unnecessary, again, touching and cross-contamination. And then the importance of things like goggles, and then with crossing the step over and putting on the clean room boot so that the boot only touches the clean side of the changing facility, not the other side. So again, that's important. About double gloving for an aseptic area, and then also getting the trainee to check how they look, whether they've got any tags hanging off, if they've forgotten to put a press stud on, if their mask is not fitted correctly. So having mirrors, full length mirrors within the changing room is really important. And then it's the case of just getting the trainee to repeat this over and over again until it becomes as natural as it possibly can. Other things that we can use are, so for like glove disinfection, then the use of UV light or UV torches, and using a photoluminescent powder or spray, for example. So it's getting the trainee to coat their gloves with potential contamination, shining a UV light on it as shown in this picture, and then getting the trainee to disinfect their hands, and then coming back to the UV light and seeing how much contamination remains. And by doing that, they can understand the extent to which they need to disinfect their hands, and that can be a powerful tool, and one that is not especially expensive. The kits can be picked up for a few £100s. Things that are more expensive but can be very effective are virtual reality. So there are a number of companies who are developing virtual reality training. So this involves wearing a headset and then seeing the vision of something. So in this case, it's an isolator, and the trainee is practicing carrying out manipulations within the isolator. And this can be useful so that people understand how to operate, how to behave, what kind of effect they could have on breaking first air or causing excessive turbulence before they actually go to the real thing. So this again can be a good way of embedding that training, although virtual reality is not suitable for everyone. Some people do feel queasy, but for those who like that, then it can be a very powerful tool. Another area is with online learning. So there are learning modules that can explain things like cleaning and disinfection, and take people through the basics and then understanding the techniques. I don't know if you can sort of see the slide at the end, the one numbered 3. here, we've got a virtual clean room, and we're putting on the directions of the cleaning in the form of arrows, and it's sort of explaining in this case that you're cleaning from the back of the room and working out, but these sorts of things can be, again, quite powerful tools. But it's also useful, as well as the practical side, is to test knowledge. So it's about asking the trainee questions. So I just picked some random questions here, but if we're going back to gowning, then you want to say, like, if you didn't tuck your hood in to the back of your suit, what would be the risk when you go into the clean room? If you put your outdoor shoes or your shoes that are less clean on the clean side of the step over before putting your clean room boots on, what do you think might happen? If you don't disinfect the step over before you put the gown or your gloves or whatever you're going to be putting on beforehand, what could be the consequences? If you're rushing the process, again, what might go wrong? And if you don't put the right gloves on at the right stage, again, what could go wrong? So it's about the trainer firing off some of those questions and getting the trainees to think about them. And if they start to think about, oh dear, what could that mean? How could that affect something? Then it stays in the brain for longer, I believe. Now, of course, we have to get across regulations as well. In pharmaceuticals, it's very rule-based, very strict, and legally defined. So we don't want to frighten people, but equally they need to know that there will be inspections, and we do need to meet strict requirements, and this is the basis of a lot of what we do. If we think about sterile products, so if we're making sterile pharmaceuticals as well, then again, getting the trainee to sort of think through things can also be very useful. So one of them is, like, what is sterile? How would you define it? Because it's often a misused word in everyday talk. And then it's sort of saying, okay, well, if we've got sterile products, is this itself good enough? And then you can start to get onto the subject of dead microorganisms and the risk of endotoxin. You can get particles that can exist in the product. If it's an injectionable, that can cause problems as well. So just talking things through, to my mind, is a huge benefit. Another thing is sort of putting everything together. So this is sort of my thoughts on the optimal process. So ideally, we want courses that are interactive. There's either a game that can be played, there's something visual to look at, a video or online training in virtual reality, and there's a practical element. We want things that are going to encourage people to think. So it's like, if you do this, what does it mean? If you do that, what does it mean? I think it's then understanding where contamination comes from, what are the risks around that. And then we need to consider how we're going to assess. Is it purely visual? Is it through group learning? Is it through a quiz, questionnaire, even an exam of some sort? But the most important thing is that it's participative, and ideally people will learn from each other. And then training can't be static as well. So there's no point saying, oh, well, we trained everyone 2 years ago, 3 years ago, and they've obviously forgotten that. That's really bad. No, it's bad if we don't keep training as a continuous exercise, because it's wasted if we're not retraining, or we're not confirming that the training is being passed on. So it's things like supervisors walking the floor, and if we need to do in things like quiet coaching. And it's also important that we attempt to evaluate our training as well. So many organizations fail to carry out effective evaluation of training and feedback, and seek to improve how we can make training better. So evaluating training outcomes to me is an important part. Even if the trainee says, look, I really enjoyed it, yeah, but did the key message get across? So what kind of KPI are we going to set ourselves? So if we're seeking to see fewer contamination incidences, then and that relates to an area of training that we've selected, then that's an important thing to try and capture. So just to sort of end with, we need to build up knowledge. We need to get across what the risks are, and if we do so, we should see fewer contamination incidences. We want to show regulators that we have effective training in place, and we want to see fewer contamination incidences. But we can only do this if we've defined our competencies, set our objectives, developed training that is lively, meaningful, participative, and lets everyone know the who, what, why, and when. So that brings this part of the webinar to an end, and I'll hand you back to Rebecca.
Thank you very much, Tim. I think I speak for everyone when I say it was very interesting and informative. So yeah, thank you for the information and the comprehensive overview. So we have a few questions that have come in, so I think we've got time for a couple. So the first one we've got is there any regulation regarding the job description of an aseptic area operator?
There's not very much in terms of actual regulations, other than a job description is required, and also if it's aseptic, that there's a base knowledge of microbiology, and there's a base knowledge of engineering. However, I think if we're going to talk about aseptics, if you look at Annex 1, there's a lot of things on there that we can draw down for key competencies. So I would work through that and tick off the gowning, the glove disinfection, the speed of movement, the attention to cleaning, all those sorts of things. But there isn't a specific regulation that says you must have this or you must have that. Unfortunately, you've got to kind of pull out those things and develop it yourself.
Thank you, Tim. Perfect. And the next question is, what is the most effective tool for conducting root cause analysis of a microbiological contamination?
That's a very big, it's almost like a webinar in itself, that one. But there are lots of different approaches to root cause analysis. But if I was going to very quickly summarize that, it would be having a good problem statement. It would be about collecting as much information and evidence as possible. Then it would be subjecting that to something like the 5 whys questioning. So we're saying, why is this, why is that, why is that, asking that over and over again till we narrow down. Then to put that information onto things like a fishbone type diagram, and then a contradiction matrix, and then kind of work towards the final answer. But I think that's something that we could probably do in a future webinar, because it's quite a convoluted process.
Yeah, Perfect. Thank you very much, Tim. We're unfortunately running out of time, so I think that's all we've got time for at the moment. I'll just move on to the next slide. So thank you very much, everyone, for attending our webinar. I hope that you found it very useful, and we appreciate all the questions that you asked. As we said at the start, any questions that we didn't get to in this session, I'll forward on to Tim, and then we'll circulate his responses along with the recording. And if you wish to catch any of our previous webinars, Tim's blog, or regulatory updates, please go to our website or keep an eye out on our social media posts. I'm quite active on LinkedIn, so there's always an interesting post over there. We also offer a range of technical training courses designed for professionals across the industry. We've got several upcoming sessions, including those detailed on the screen, and we have more scheduled throughout the year, so keep an eye out for that. And you can find full details and registration links on our website. And please also remember to check the website for future webinars. So thank you very much, everybody, and have a great rest of your day.
Thank you.